Hello, Haley backwards here, trying an experiment with off-the-cuff screencast. Today's topic is RadarScope. Also, today's topic is that it's November 7th, and Oklahoma, having just been through its historic earthquake, historic for the state, 5.6, is now in the middle of some tornado warnings. So if we zoom out, to give you more perspective, here's Oklahoma, there's the Panhandle, and there's your tornado warnings. Now, since this is live, they may well disappear as I'm doing this. That's why it's a large experiment. So, this was the first one. This one looks kind of like it's dissipating. So what I want to show you, this is I don't know, the type of stuff that I look at when I stare at radar. So to me, it looks like this one's probably going to get called off. So one of the things you can do is the info window. Bring that up, and I believe it will default to this, actually. So what you want to do is hit the pop-up menu and choose warnings. So you can also use this to zoom to one or another, and then you get the text down here. So you can see things like, you can read, like, was it indicated by Doppler radar? Are there storm spotters on the ground who have actually seen and confirmed that there was something going on? If I remember right. Yes, spotters have recently reported a funnel cloud with this thunderstorm. Okay, and here's your brief breakdown if you're not familiar. A funnel cloud is not a tornado. It can be, it's not, it doesn't have to be a precursor to a tornado. I mean, it's always going to precede a tornado. How do I explain this? A funnel cloud does not necessarily become a tornado, but a tornado will always have like a funnel cloud before it. So it's the thing when it starts looking quite tornado-y, but it hasn't touched the ground yet. And here's one thing you can tell. You might not always be able to see it going from like the cloud all the way to the ground. Look for the debris ball. That's not the word. The debris thing on the ground, because, you know, it might not be completely connected. So that's what you look for, is debris on the ground. But anyway, in this one, I'm going to see if I can pause this and back it up. Apparently not. No! Previous. This one kind of had a little... It's kind of hard to tell with... This is level 3 radar data, if I remember right. But you can see kind of that hook thing going on, where there's a little bit of a notch. And if I remember right, the one that just came out looks even more hooky, echo-y. So that's helpful. But you can, I need to stop clicking that button apparently. You can tell as you forward through this, to me, it looks like it's dissipating. Well, dissipating tornado-wise. So, but let's look over here, where it definitely, to me, looks like there's a hook echo going on. But I am not a meteorologist. Perhaps I'm just completely mental. But so, whoops, did not mean to do that. So what you're looking for when it comes to hook echoes, and let me first say, not every tornado comes with a hook echo, if I remember correctly. So just because you can't see a hook echo on radar does not mean that there might not be a tornado on the ground. So yeah. So what you're looking for when it comes to hook echoes is some sort of notch. Now you might see demonstration-ish images where, like, there's a tail. I don't know if that's what it's called, but like the tail that's here would be over here, and then there's the notch here, and then there's the main storm here if it's like booking east. So that's what you have to like train your mind, is to stop thinking that all storms move east. Like this one is booking, what is that, going northeast, I would say. Oh no, so that's the hook echo tip. That's base reflectivity. 95-ish% of the time, what you're going to be seeing when someone refers to radar is base reflectivity. But there's a whole bunch more of them. I have no idea what all of these things are. But base velocity is another one to think. And look at that. That's a rotation couplet, I think that'd be called. So I looked it up, and frankly, I'm not sure if I know how to describe this properly, but you've got base velocity and you've got storm relative velocity. And look at that. That one is quite bright as well. So, if I remember correctly, base velocity is like this black hole. That's where the radar site is. So base velocity that's just how it's moving period. Whereas storm relative velocity, and frankly I have no idea how it works, apparently takes into account storm motion. So it subtracts somehow the overall direction that the storm is going, and the point there being that sometimes, because of the storm motion or whatever, you might not see a real bright couplet where, like, maybe it would be two sides of the same part here. I don't know. But anyway, so that's one other thing you look at. That's what you do. I have no idea. Anyway, base velocity. Basically, I go after whichever one looks prettier because I'm a girl. That's right. I'll make it all sexist and say, I like the pretty tornadoes. Uh-huh. Anyway, so yeah, I guess that's it. That's what you want to look at. Radar, warning stuff. Make sure you know how to loop it. And yeah, look at that. That's quite the rotation couplet. Oh, yeah, let's read it over here. Now, it's spotters. Am I looking at the right one? No, I am not. Tornado warning. Spotters observed a tornado 7 miles west of Frederick, moving northeast at 35 miles per hour. Oh yeah, that's something else. RadarScope, as far as I know, does not have this. Or actually, I think they do, but you have to pay a third party to get this data. Anyway, if you're a nerd or something, you can look at this stuff over here and actually see where they're indicating that the tornado is going. But if you don't want to do that, you go to Wicked Wicks, and I'm going to stop this and do some another segment. Well, I'll show you how Wicked Wicks has the storm path thing going on. Anyway, yeah, so this is not an ending. Okay, part 2. We've got Wicked Wicks. This is wickedwx.com in case you can't read. We've got it loaded with the tornadoes. Now, it's kind of cluttered right now, but on this site, there is the storm path. So that whole little bit, well, let's see if I can show details. This little, where is it? Yeah, this thing. This little line gets passed. So that you can get these lovely little arrows or something. And if you turn off radar, it makes it a lot easier to see. So, based on the current warning, so we've got tornado, severe thunderstorm warning. So it shows you, this is based on what's in the radar, the warning data. This is where it's predicted to go, or something. And then you can also change to Google Hybrid. That might be a little easier, more contrast or something. Turn the radar back on. It'll probably look horrible. Yeah, you can't hardly see them at all. Here they are. There's the lovely actual map layer, if you want to get rid of them, if they're distracting with the arrows. But anyway, yes, and I found the image that I want to talk about. This is where I got all of my knowledge. Storm relative velocity versus base velocity. So you can go to that URL and look up this image yourself. But they've got an example where with the base velocity, in this case, it'd be very difficult to see that there's like some rotation going on in there. Well, difficult to a human, because I bet the computers know, man. They've probably got their algorithms working on it all the time. But anyway, if you switch over to storm relative velocity in this instance, very much you can see a couplet there. So yeah, I hope you've enjoyed this wonderfully long, live blogged, off-the-cuff presentation. If you want more information on weather, I don't know, you could ask me, even though I don't know anything about it. If you want another RadarScope tutorial or something, ask me and I'll read the manual for once. Anyway, so hopefully you're not in the path of the tornado. And if you are, I hope you're already undercover. And obviously, you would be not watching this right now because it's not even uploaded. That would just be really weird. And a distortion of the time-space continuum. Anyway, I've totally rambled this ending. It's not even an ending. So I just say, goodbye.